you very much, Marco. So thank you everyone for coming to this session. Hopefully this should be a bit of fun. So my name's Jim Bennett. As Marco said, I'm a cloud advocate of Microsoft, and I'm an IoT enthusiast. But I'm also concerned about wildlife. Something else. Yeah, I'm passionate about IoT, but I'm also passionate about wildlife. And I want to kind of open with this very depressing statistic that we lose one elephant from the planet every 15 minutes thanks to human activity. We have poachers who will kill these beautiful creatures, cut off their tusks because people want to buy them, cut off their feet to make waste paper baskets and umbrella stands, cut off their tails to make fly swatters. And there's just this horrific trade in parts from elephants. Now, it's not just poaching that's damaging the elephant numbers as well. Elephants are migratory. They go from the river during dry season, lakes, ponds, to lush grass areas in the rainy season. And they travel a long way potentially when they're doing their migration. And sometimes humans get in the way. Elephants will cross over where humans are. Humans don't like it. Humans kill the elephants. Or elephants will just get lost. They'll be confused because there's suddenly a town there they weren't expecting, and they end up not being able to go to where they need to be. Now, it's not just elephants. I mean, we say we lose one elephant from the planet every 15 minutes. You know, at this rate, we're going to lose all the elephants on the planet in the next 10 years, which is pretty horrific. But there's other animals as well that are highly, highly endangered. Now, you're probably wondering, why am I starting an IoT session by talking about animals and conserving wildlife? But really, I'm talking about this because I believe things like IoT can help us preserve wildlife, help us protect these beautiful creatures from humans, from essentially extinction. And so I'm going to be showing off a lot of IoT demos today, all focused around how we can use IoT to help protect wildlife. So as I said, I'm Jim. I'm a friendly chap. I know my stuff about IoT, but I'm always interested to learn about what you're doing. And I always want to be here to answer your questions. So my job is to support students like you, educators, and help you be successful with Microsoft technology, so specifically the Internet of Things. And you can get a hold of me all over the internet at Jim Bob Bennett. So Twitter, GitHub, Instagram, LinkedIn. Please connect with me. I want to hear your questions. I want to help you if you get stuck with anything with the Internet of Things. And I want to celebrate your successes. You know, when you light that first LED, I want to know about it so I can celebrate with you. When you build a cool project, I want to know about it so I can celebrate with you. So please get in touch, share any IoT work you do, and say I'm here to help you with all of your IoT activities. Now, we'll leave you with this link, aka.ms/IoT for everyone. So if it's too late in the day and you find yourself tuning out and you don't remember anything I say, this is the link to go to, aka.ms/IoT for everyone. You go here and there's a load of resources, how to connect with me, and just resources around all the topics that I'm going to be talking about today. So this is kind of your cheat sheet for today. Now, I do want to take a moment, just kind of set a baseline here, make sure we're all on the same page, and talk about what is the Internet of Things. Yeah, this is a session about IoT within the Microsoft Azure stack, but what is IoT? What is the Internet of Things? Now, Internet of Things essentially is made up of two components, the Internet and a thing. Now, I know that sounds a little bit silly, but that's kind of basically how it works. You have a thing, a device that interacts with the physical world. So this thing is usually a low-powered, small computer. It will have sensors on the computer, and these sensors will detect the physical world around it. Same as you have senses, you may have hearing, sight, smell, touch, taste, your sense of balance. These things have sensors too to detect the things around the world. They may detect temperature, pressure, vibration, rotation, light levels, noise levels, all these different things the thing will detect. The thing will then send that data to other things. Maybe you have multiple things connected via some kind of mesh, or the thing is connected to the cloud. And the data then usually ends up in the cloud somewhere on the internet side, where you will process the data and make decisions. And then from that data, you may send requests back to a thing to do something. So things, as well as sensors, can have what we call actuators. And these are kind of like the opposite of a sensor. They convert a request into a physical action. So they might be a speaker or a buzzer, turning a light on, flipping a switch, starting a motor. some kind of physical interaction. So device reads a physical property, sends it to the cloud, do some analysis, sends a message back to the thing that interacts back with the physical world. That's kind of what the Internet of Things is all about. Now, kind of one classic example that I think makes it easier to kind of understand this concept is a smart thermostat. This is kind of the canonical example that we all use. So 20, 25, 30 years ago, when I was growing up, the thermostats we had were dumb thermostats, no smarts behind them. And this was literally a box on the wall with a dial, little temperature sensor inside. You would set a temperature, and then when the temperature went below that, it would turn on a relay, which is an electrical switch, turn on a heating system, and heat would come out. Then when the temperature goes up, turns off the relay, turns off the heating system. All very dumb. Now, what I have in my house now is an Internet of Things heating system. So I have got, in my hallway out there, I've got a box, an LCD display, and I can set from the box the temperature I want. I can set schedules, this temperature in the morning, this temperature in the evening, this temperature at night, things like that. And it's connected to multiple sensors all around my house. So these little tiny sensors detect the temperature in my bedroom, my office, my living room, measure the temperature, send that all to the central thermostat. So you have multiple sensors gathering temperature data, and that thermostat sends that data to the cloud and then makes decisions on how to heat or cool my house. It's not just a binary, the temperature's too low, turn it off, turn it on, what have you. It looks at those sensors. It looks at the trend in the temperature. It looks at what my schedule is. So if the temperature I've requested is 20 degrees and the temperature on the different thermostats is saying, well, we're 20 upstairs, 19 downstairs, and we're going downwards, so we probably should turn the heating on. But if it says we want 20, we're 24 upstairs and 19 downstairs, we don't want the heating on because upstairs is too hot. Or if the house is, I want 20, the house is at 19, but in 10 minutes the schedule wants it to be 19, then there's no point in heating it because by the time it starts to warm up, it'll be time to get cool again. So it brings in smarts like that. It can even look at things like the weather. It's going to be a hot sunny day, so let's not bother putting too much heat out because we're going to get heat from the sun. I could potentially wire it up to my calendar so it knows that I'm on vacation, there's no point in heating my house, and kind of bring all these smarts to it. So it's not just a simple temperature goes below this, turn the heating on. It's a whole intelligent system that manages the temperature in my house. And that means my house is at the ideal temperature, and it can save me money. It can be much more efficient with how it uses how it uses my heating system, which reduces obviously things like carbon emissions and is good for saving me money. So that's kind of a canonical Internet of Things device that a lot of people have in their homes. So what can we do with IoT? Yes, I've mentioned my thermostat, but what can we do with IoT? How can we use the Internet of Things? And there's actually kind of 4 areas where we can really use the Internet of Things, kind of 4 big groupings of Internet of Things devices. So we start in the home with consumer IoT. And this is devices that you as a consumer will buy to use in your home. Smart speakers, if you've got an Echo or a Google Home, one of them. Robotic vacuum cleaners, voice-controlled ovens and taps and health monitors and time trackers and Alexa-controlled toilet cleaners and automatic garage door openers and all these kind of devices you would have in your home to automate a number of the tasks that you do. Behind me, I've got lights and I've got buttons I can press and the lights will change color. That is a IoT device. It's connected to the cloud, controlled via the cloud. I have, in my office here, I have a rowing machine. That's all connected to the cloud, so that tracks my workouts. I can track it from my phone. I've got a smart garage door opener. My fridge will send me a notification if the water filter needs changing or if I leave it open. Kind of all these different devices that are connected to the cloud. And what's really powerful about these, is what they can offer people with disabilities. So, for example, I can control my garage door with my voice. I can walk into my house and say, Alexa, shut my garage door. I cannot say, Alexa, open my garage door, because that would be a security risk. Because then somebody could lean through my window, shout, Alexa, open the garage door, go in there and steal something. But I can close it with my voice. Now, this isn't just me being lazy. This isn't just me being, I can't be bothered to get my keys out of my pocket and press my little dobber. This can actually empower people who don't have the fine motor skills that you need to press the little tiny button on the remote. So if I had a permanent disability that limited my accuracy with fingers, I may not be able to press that button. So I could then use my voice to shut my garage door. That empowers me to do something. But disabilities come in multiple forms. So you have permanent disabilities, you also have temporary disabilities and situational disabilities. Now I live 45 minutes away from the mountains. I would go off, go snowboarding, fall over, break my hands, have my hands put in plaster. I would not be able to press the little tiny button to shut my garage door. Alexa, close my garage door. So that situational disability, the IoT device allows me to get over that. Sorry, temporary disability allows me to get over that. I'm also a parent. I have a kid. You've had kids, you have younger siblings that you've had to deal with. You may have had the situation where you're kind of coming into the house, you've got a child under one arm, shopping under the other, and it's like, I don't know what to do with all my stuff. I can't close my garage door because I've got all my hands full. So what you can do is, again, I don't have to put my kid down, I don't have to put my shopping down. Alexa, shut my garage door. So when I got that situational disability, then I can use my voice to control it. So these consumer IoT devices are incredibly, incredibly powerful. So one question just come in: how can people use these devices Arduino in their everyday life? Can they use them without knowing programming? So you can buy consumer IoT devices that you can set up, and there's a lot of these consumer devices. So things like switches. I can buy a switch and I can very easily control it in many different ways. So I've got Christmas lights outside my house. We're a household that celebrates Christmas, and I can use my voice to turn those on and off. So I can control those lights without programming. If I wanted anything more advanced, I would need to learn some kind of programming. So for example, these lights behind me here, if I press buttons, they change color. I've written the code to control these. I could buy lights that do this, but I had a very specific requirement for the lights, so I wrote code to control this. And this is all Python code. This is a Raspberry Pi running Python, which we'll actually cover a little bit later. So if the consumer device does what you want, then yes, you can do that without knowing programming. But if you want anything a bit more specialized, then you would need to actually write some code, which is, as you ask, so C++ for Arduino, but you can use things like a Raspberry Pi where you can use Python or other languages. Great question. Consumer IoT devices, a lot of off-the-shelf ones, anything specialized that you want to build yourself, it's time to write some code. Cool. Great question there. Great question. So as we move up from consumer IoT, we move into commercial IoT. And this is IoT in the workplace. This is things like occupancy sensors, motion tracking, and the safety tracking, temperature tracking, vehicle tracking, things like that. In this, our time of COVID, maybe you want mask tracking. Make sure all faces are wearing masks. Hard hat tracking is incredibly important on work sites. Those things like occupancy and motion tracking can be really useful for saving energy. Say you have a meeting room. If there's nobody in the meeting room, turn the lights off. Turn the heating off. You can combine occupancy sensors with calendars. So if you have a meeting rooms where you have to book the meeting room on a calendar, it can say, well, there's no meetings booked today, turn the heating or cooling off, save money. But if somebody goes in, let's fire that back up again. So you can use this kind of save energy, reduce your carbon emissions, things like that in large buildings. It can look at the global calendar of the company. We're coming up to the winter holidays. Where I am in the US, we get some days off for Christmas Eve, Christmas Day, and New Year's Day, except we get the day before because it's on a weekend, but the buildings don't need to be necessarily powered up during those days. So if the building is connected to the calendar, it knows we can turn the lights off, turn the heating off for these days and not turn it back on again until the following Monday. Vehicle tracking is another really important one. This is a really big growing area. There's a lot of problem at the moment for roads in countries is that most countries start off by taxing people at the pump. So when you fill your car up with fuel, you pay tax. That tax pays for the roads. As vehicles get more efficient, we move to electric vehicles, hybrids, that tax take drops. But then, especially when you have large trucks with a lot of stuff being delivered, because we all want to buy rubbish from all these various delivery companies, these trucks damage the roads, but they're not paying back enough to repair the roads. So there's a lot of countries looking at how they can charge you based off the amount of road usage you use, not the amount of fuel you use. In New Zealand, one example, if you're a just standard consumer car, petrol, tax at the pump. Commercial vehicles use diesel. You don't pay tax at the pump. You pay tax for every mile you drive on public roads, but just on public roads. So if you're driving a logging truck 10 miles on public roads, then 15 miles round a logging site to cut the logs, and then 10 miles back on public roads. You've driven 35 miles, you only need to pay tax for 20. And so there are companies that produce vehicle trackers that track when you're on the road and tax you accordingly. And this has been trialed in the US, there's talk about this across Europe, and so vehicle tracking is a big way of doing this. Insurance companies are looking at it for reducing your insurance bill by proving you're a smart driver. So it's all down to an IoT device in your car. So commercial IoT, huge area. Scale up again, we hit industrial IoT. This is factories, this is farming, this is millions of sensors in a factory to monitor all your hardware and make sure all your equipment's okay. You would have vibration sensors on machines that would look for certain patterns. AI models that would actually monitor the data. If it vibrates in the way it's expected, we're all good. But if you get a different vibration that it's not expecting, then that's an alert that something could be about to fail. You could train AI models on the different vibrations, and you know that pattern A means the flux capacitor is about to go. So when you spot pattern A, you can predictively maintain that. Somebody can get a new flux capacitor and fit that to your machine before it actually breaks. So you reduce your downtime. Farming, digital agriculture, absolutely massive. The developed world is really pushing this, whether it's GPS controlled, combine harvesters, harvest time, water monitoring, so you only water when you need it, monitoring pollution runoff, monitoring soil nutrients, monitoring crop growth, doing temperature measurements to predict harvest readiness. All these things, they are using to be much more efficient on industrialized farms. And this is starting to spread to the developing world as well. Just the ability to monitor soil moisture and only water what you need is super important in countries where water is a very limited resource. So industrial IoT, really big use case of Internet of Things. Then we scale up one more time, we hit infrastructure IoT. And this is the Internet of Things at a city or country or potentially even global level. So this is where you do things like you have smart grids. So you monitor energy usage. Now, when you produce electricity, you have to produce enough for the peak demand. And so if you can be smart about this, if you can say only charge electric cars at night, you can reduce the peak demand. So you not end up producing excess capacity. And all that can be discovered by running smart grids, running smart meters in your house to measure how much electricity you're using. Look at transportation. If you know where cars are coming from, where they're going to, you can maybe build more public transportation. Things like pollution as well, monitoring the environment. Where I live, in the Pacific Northwest of the US, we had a heat dome back in June. Big, hot dome, went over 40 degrees Celsius. And they noticed in some cities that the temperature on roads without trees was substantially higher than the temperature on roads with trees. This is good urban planning data. Comes from IoT devices, but allows you to decide to plant more trees because it's good for keeping the temperature down. So you can use infrastructure IoT for things like urban planning, making sure your city is better. So the other topic, the other use of IoT, which is one I kind of want to focus a little bit on today, is IoT in conservation. We'll just take this quick question, which is there any significant cost difference between ready-to-use, off-the-shelf devices and DIY kits like the Arduino? Yes. It can vary both ways. If you wanted a smart plug, just go and buy one. Order one off Amazon. They're $2 or $3. To build the same thing would be very, very expensive. A smart lighting system like this, where I've got the button on my desk to control the whole thing, would be probably more expensive to buy this as an off-the-shelf device, because I want a very specific thing that fits to my shelf. So I bought Raspberry Pi, some lights, cut the lights up, fitted it in. And so this was much cheaper because I want something very specialized for what I want. I'm going to put, at some point, IoT lights all around my house. I'm going to get professional to install the lights, and then I'm going to build the control circuitry because that will be slightly cheaper because it will do what I want. If I want custom control circuitry, it'll be very expensive, but I'll build that myself. If I just want a simple temperature sensor so I can just see how warm my house is, or just want a simple soil moisture sensor, building that yourself is cheaper than buying a commercial option, but then you have to put the work in. If you've got the time to do it, it's cheaper. If I wanted to automate my watering system based on soil moisture, I've got the parts, but the parts to do it, the hardware to do it, would cost me, $20, $30. If I buy the commercial solution, that'll be $150. But it will take me a day probably to get everything set up if I do it myself. If I buy the commercial solution, plug it in, and I'm done. So it's not just the cost of parts, it's the cost of your time as well. So if you build it yourself, it's usually cheaper, but takes a lot more work. Yeah, great question. Great question. It's a really good way to actually explore and experiment. If you think about things you want to do to automate your house, find a consumer IoT device and build it yourself. That's a great way to learn how to do things. Great question. So we talked about IoT in consumer, office, workplace, industrial scale, and then infrastructure scale. But let's talk about IoT and conservation. Let's talk about how we can use the Internet of Things to preserve wildlife. And one of the simplest things we can do is just track movement. So female polar bears, when they're about to have cubs, dig themselves a den, hide in there, hibernate, give birth to cubs. And then when they're ready, they pop out. So maybe what we could do, if we wanted to find when polar bears pop out, so we could then send rangers in to maybe tag them or just monitor where they're going, maybe you just want a simple IoT device that detects that movement, just detects when something pops out. Maybe if we want to monitor animals at a waterhole, we want to find out when the wildlife are coming to a waterhole as it starts to fill up, we could just simply track some form of movement. Have a sensor that picks up when something is there, and then we can use that in an IoT device and use this to start looking at how we can use IoT to track conservation. For example, we could use this, so if we know when the elephants are coming to the waterhole, we know when we can maybe send more rangers to the area to protect against poachers, things like that. So tracking movement is kind of a good first way to think about how we can use IoT in conservation. There's a million different ways we can use IoT. Smart collars are a big one. Machine learning models to identify noises from animals are a big one. But we're going to start simply with just tracking some form of movement. So let's do a demo. Let me show you an IoT device I can use to track movement. So I'm just going to zip to my camera here. This is my IoT device. This is based off a Raspberry Pi. You can't see the Pi because it's in a case with a hat on it, but this is what one looks like. This is a Raspberry Pi. This is an awesome IoT device. You can pick these up. They start from about $35 US, and they're designed by Raspberry Pi Foundation in the UK, an organization that teaches kids how to code. That was the original idea. And this is a fully featured Linux computer. 2 4K HDMI ports on there. You plug in monitors, 2 if you want. Plug in a keyboard and mouse into USB sockets, and you've got a fully featured Linux computer. Runs Raspberry Pi OS, a version of Debian Linux. There's a quad-core 1.5 gigahertz processor on here. They start at 1 gig of RAM, go up to 8 gig of RAM. So, these are pretty meaty machines for starting at $35. And what's cool about them is they have these pins on here. GPIO pins, general purpose input-output pins. And I can connect IoT devices to these. And being a general purpose computer, I can program this in any programming language I want. This is not Arduino, this is not C++. If you can program that language on Linux, you can do it on here. I use Python. That seems to be the standard language most people use for IoT devices on the Pi, but you can use .NET, JavaScript, Java, C++, Go, Rust, you name it, you can run it on here, which is pretty cool. So what I've got on here is a hat, as they call it, a hardware attached on top, I think is what hat stands for, and it kind of sits on the GPIO pins. This C, you can use C if you want to. Use any programming language you like with a Raspberry Pi. C, C++, Python, Java, JavaScript, you name it, you can program it. I use Python because there's a lot of Python libraries for IoT hardware. So on here, this hat comes from Seed Studios, company in Shenzhen, special economic region of China, and this provides you with a nice way of connecting sensors. Slides on the GPIO pins and has these standard sockets. Some are analog, some are digital, sockets to different things, but these sockets you can then use to plug in other sensors. So I've got a cable, standard cable here, plugs in to a bit of hardware here, and this is what's called a time of flight sensor. So it's a distance sensor, this one here. Sends a laser beam out, picks up the backscatter from the laser beam. Ignore the other cable, we'll come back to that later. But this I can use to do a distance measurement. So this sends a laser beam out, and if anything breaks the laser beam, I get a distance measurement. So if I go here, get my window, decides to reload. I'm using Visual Studio Code here, and I'm actually coding on my Raspberry Pi. So Visual Studio Code has a thing called Remote SSH, allows you to connect remotely to a device like a Raspberry Pi. So I'm logged into my Pi, I'm on my Mac, I'm connected remotely to my Pi. I've opened a folder on my Pi, I can debug code on my Pi, so I can run my IoT code locally from my Mac, but it's all running on my Pi, which is pretty cool. So if I just run this app. So this is measuring distance, giving me a distance measured of 8.191 meters. That's basically saying, yeah, the ball's too far away for it to pick up. And so if I have my polar bear come up, so here's my polar bear, it's in its den, ready to pop up. And up it pops. As I look around, goes away again. My distance sensor, goes away. My distance sensor detects it. So it detected an animal at a range of 0.177 meters. So it's picked up that the beam has been broken and we've measured something. So up pops my polar bear again, animal detected. If I go a bit further out, animal detected. So it gives me the distance to the animal. So I can use this to see, has my polar bear popped up from its den? Do we have animals at the waterhole? Yeah, if something's broken the beam, I have detected something. And I'm sending this up to the cloud. Obviously, there's no point in having this on the device if, I'm not going to be remotely connected to my device staring at the output, the file. I'm sending this up to the cloud. I'm building a JSON document that's going up to the cloud. So what does that mean when I say it's going up to the cloud? So what I'm doing is I'm sending it to a service called Azure IoT Hub. Now, Azure IoT Hub is kind of the first point of the whole IoT ecosystem that we have at Microsoft. It is, I like to describe it as a big fat pipe. You can connect IoT devices to it. 1, 10, 100, 1,000, million, billion devices. Connect all these devices to Azure IoT Hub, and they send messages in. And then IoT Hub acts like a message broker. So the messages go in, and then other things can subscribe to those messages. So I send an IoT message from my device, it goes into IoT Hub. It doesn't get stored, it gets stored for about a day so that someone can read it and then it gets lost. I don't get any charts and graphs, I can't plot my data, it's just a pipe. It's just this big message bus. But other things can take messages off and process them. An IoT Hub is very low level, very fast, it can process billions of messages a day, messages go in, something else takes them off the other end. So when I'm building an IoT application, I would have my device send it to the hub, and then I'll start building services to pull it off. And we'll look at some of those in a minute. Now, if I'm connected to IoT Hub and I'm sending stuff over, I need to consider security. Now, there's an old joke that the S in IoT stands for security, because there is no S in IoT. And it's true, when IoT devices first came out, they were very insecure. And a lot of consumer IoT devices are still very, very, very insecure, which is really worrying. Before you buy any consumer IoT device, do a quick search, Google it with Bing, find out about that device, whether there have been any security breaches. It's very worrying just how bad there are with some of the security problems with IoT devices. But you need to be secure. IoT Hub is secure by default. You can't have any devices connecting. If you build out spin up your own MQTT broker, for example, which is a low-level messaging protocol for IoT devices, if you set up your own broker to send IoT messages to, and you forget to turn on security, you are asking for trouble. IoT Hub has security baked in by default. One of my favorite IoT security stories, I love this story, is how a casino in Atlantic City in the US was hacked, data was stolen, thanks to a fish tank. So what they had in the casino, they had a tropical fish tank with a temperature sensor in it, thermometer. And this temperature probe would measure the temperature and then adjust the temperature of the fish tank, and it would send data to the internal casino network. Now, if you've ever bought a consumer IoT device, what you've probably had to do is get your phone out and connect to a wireless access point that runs on the consumer IoT device. So the IoT device will advertise an access point, usually named after the particular device or manufacturer. You connect it from your phone. You then fill in a form that puts your Wi-Fi credentials, copies that onto the consumer device. The consumer device will then connect to your Wi-Fi and turn off its access point. And then if you need to reconfigure it, you would factory reset, turn the access point back on. In the case of this temperature sensor, the access point was never turned off. So the casino, they put it in, connected from their phone to their temperature sensor, set the Wi-Fi credentials so the thermostat could connect to, the temperature probe could connect to their internal casino network, rebooted it, all good, left it at that. Hackers came along, connected to the open access point on the temperature sensor, and once they connected there, they were able to hack through into the internal casino network, and they pulled out so much data that they needed. So you've got to always consider security. Always, always, always think security with IoT devices. So IoT Hub is secure. You can't connect if you're not allowed to. So this is IoT Hub. This is the admin console really for IoT Hub, and it's not very interesting. I can see things like the number of messages being sent each day. I can see 115 messages today. I'm allowed to send 8,000 today if I want to. How many messages come through at different times? Number of connected devices. Yeah, this is just an admin console. I can't see the distance measurements. I can't see the data that comes in. I can just see that there are devices connected because this is just a big message pipe. But with security, when I set up a device, my device has to be secure. So one way to set up a device is in IoT Hub, I add a device. And when I add it, I have to either set a key or a certificate. In my case, I've got a key. I'm going to be very insecure and show you my key, but I'm going to rotate these keys later, so they'll be gone by the end of the session. But this is my magic key. So when my device connects, it has to pass this key. So my device has to be secure. This is not open. Devices can only connect with the key, and I can control those keys, manage those keys. So that kind of gives me that security by default. I have to be secure by default. So data's going up to my hub. I've got my device, my polar bear pops up, takes a distance measurement, sends it up to IoT Hub. What do we do next with that? We've got some data. What do we do next with it? Well, things IoT is all about data. It's not just about the internet and the things, it's all about data. As an IoT engineer, a data scientist is your best friend because IoT devices generate a lot of data. You know, they reckon we're about to hit 80 zettabytes of data, which is like 80 trillion gigabytes of IoT data. That is a stupid amount of data, and most of it is never, ever used. You've got devices just gathering all the time, sending data, goes into storage, and everyone forgets about it. So one thing is you need to consider things like, how much data should I gather? How often should I gather my data? What's the right data? You know, my thermostat in my house, there's no point in capturing the temperature every second, sending that to the cloud. I don't need to know that. Maybe when the temperature changes by ½ a degree, then you change that, and then we can just extrapolate a simple line chart of my temperatures, but it doesn't need to be every second. It's just a waste of data. But we need to think about how often we need to capture. What is the right data we need to capture? Does my thermostat need to capture weather data? Probably not, because it can usually get historical weather data from somewhere else. You know, so things like that is what is the right data to capture. When we've got our data, capturing the data, data's an IoT Hub. What do we do with it? Where does it go next? What do we do? So let's look at a demo of stuff we can do. And what I want to show off is an Azure function. So Azure Functions is serverless code. Serverless, there are servers. It's just a slightly confusing name. Serverless code is what's called event-driven code. So Azure Functions allows me to write a function in my code, and this function is run every time an event happens. That event could be like a database trigger. So every time an item gets put into a database, my code is run. Every time somebody makes a web request, my code is run. And Azure, the whole cloud infrastructure will scale this up. So if my code gets called once, if one item gets put in the database, my code is run once. If a billion items get put in, my code is run a billion times. And the serverless side is that the Azure Functions will scale everything for me. So I've got a function here that gets triggered by IoT Hub. It's what's called an Event Hub trigger. Now, the reason it's an Event Hub trigger, not an IoT Hub trigger, is kind of under the hood. IoT Hub is actually based off Azure Event Hub, which is a message broker. So Event Hub is a way of sending messages, big fat pipe, messages come in, messages go off. IoT Hub is kind of a specialized version of that for IoT devices, so it can manage device security. And so with my IoT Hub, I have an Event Hub compatible endpoint, as they call it, and I can use this to connect, and I take my endpoint here, and I use this in an Azure function to give me code that gets run every time an IoT event is triggered. Now, what my code is doing here is just saving the IoT data to a database. I'm saving it to a database called Cosmos DB, we don't care about that. Really what we care about is I can write a function to save data to a database. And so if I actually run this, start my Azure Functions app, with a few seconds to spin up. It's going to connect and process all the messages that have been sent so far today. And if I actually get my polar bear to pop up again, you'll see, oh, we've got another message come through at a distance of 0.217. And so what's happened is in my code here, I've done a detection, I've sent a message to Azure IoT Hub, and my Azure function here has picked this up and processed it and saved it to a database. And here I can do whatever logic I want. I can filter my data, manipulate my data, whatever. And just in my case, I'm just saving it to a database. Then once it's saved to a database, I've just got a little chart here where I plot that shows my data. Yeah, it's, again, the data scientist is your friend. The data scientist will tell you what data they want and how they're going to process it. This might be of value to a data scientist. This could show that, yes, at this time on this day, we had lots of elephants come down to the water hub. And this time on this day. And so you can build up data from that. Or maybe I want an instant alert. Maybe in my Azure function, I say, oh, I've detected a polar bear popped up. Alert me straight away so a ranger can go and check on it. Things like that. So we've kind of got quite a bit of flexibility as to what we can do with our data. Now, this data isn't the smartest data, the data I'm capturing right now. Because if I go back to my little thing here, if I wave my polar bear in front of it, up it pops. If I wave my hand in front of it, same thing. Yeah, get my camera out so you can see it's my hand. No, this is not a polar bear. This is my hand. This could be a lump of ice. Could be an Arctic fox. Could be a, whatever. We're maybe looking for elephants. It could be an impala. So we need to maybe add a bit more smarts to our data. We can add smarts to our data gathering and smarts to our data processing. And this is where AI comes in. As an IoT engineer, as well as having a data scientist as a friend, an AI engineer is a good friend to have as well. Because we can use AI to take the data that we've got, analyze that data on the way in, make decisions on it, and then maybe analyze it on the way out afterwards. Maybe in the cloud, we'll run some AI models, things like that. So AI becomes our friend. Now in the Microsoft world, we have some pre-built AI. So you don't even need to be an AI engineer. You can literally just take pre-existing AI and run REST SDKs against some AI services to get the power of artificial intelligence in your code. One particular one I want to focus on here is a thing called custom vision. Custom vision is a tool that you can build image classifiers and object detectors. So these are vision-based AI models that could classify an image. So it can tell you whether it's a cat or a dog, or it can detect objects. So it can tell you there's a cat here, 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 and here in your image. It doesn't take much data. You can train these models with only a few images, and then you get a model that runs in the cloud that you can then use from your code. So as a demo of this, best thing to do is show it off in a demo. If I zip over here, I've got a model here I've trained to identify polar bears and lynxes, simply because those are the two nearest cuddly toys to hand. I didn't have an Arctic fox to hand. I've only got a lynx or a polar bear. So I've trained up my model. So the way you train it is you give it images. I've got about 45 images, I think. 31 contain lynxes, 24 contain polar bears. Click on this. I upload the image, I draw a box around it, say this is a polar bear, this is a lynx. Go through them, drawing boxes around it, and then say to the model, go off and learn. The model then learns how to recognize these, and then if I give it an image, it'll tell me, tell me this one here, it'll tell me that this is a polar bear. It's detected a polar bear in the image. So I can use this to filter data. But this here is not a polar bear, that's my hand. And so I can use this model from my device to filter my data. So if I just go back here and stop this one running, I've got another bit of code here, and this connects to my AI model. So I can take my AI model, I can publish it, I can get some connection details, and then use this from an SDK to run images through my model and use that to filter my data on the way in. So if I just go back to my camera, here we go. This is a camera on my Raspberry Pi connected via cable. So I can use that to take a photograph. So my IoT device, I start this up. What this is going to do, it's going to have the same distance measurement, but when something is detected, it's going to take a photo, send it up to the cloud. find out what's in it, and then if it's a polar bear, send the data up to the cloud. So if my polar bear pops up, you'll see we have detected a polar bear. Do my links as well. There we go. We have a links. Do my hand. Nothing. So we're not sending a message from my hand. So I can use this to say, well, I only care about endangered species at the waterhole. If it's an impala, don't care. There's millions of things. If it's an elephant, I care. If it's a leopard, I care. If it's a zebra, I don't care. Things like that. So I can use this to put smarts in there. And then I can take my data and with the help of my data scientist, I can get a different chart. So rather than just, this is when things were spotted, I've now got a chart that shows me when polar bears and lynxes were spotted at different times. So I could have this chart, and I could use this to say, okay, the lions have arrived a few days before, the elephants came later, the zebras like to drink in the morning, the crocodiles like to drink in the morning, so crocodiles going to get a nice breakfast of zebra, things like that. So I can use this data in smart ways. So suddenly my IoT device has got a bit more powerful. It's recognizing the things, filtering that data on the way in. Now, one problem we have to think about here is connectivity and bandwidth. I am sending a photo from my device, and photos are relatively large pieces of data. So to do IoT, I need to have that internet connection. So I'm sending up a packet that's got something that's being detected, small bit of data, and now my new model, I'm sending up a packet that's got an image. Send this image up to the cloud, process it, get the results, send the data up to the cloud. But what about connectivity? What about bandwidth? We don't usually have great connectivity around a waterhole. You probably don't get Wi-Fi out on a river in Africa. Don't get Wi-Fi. So we need to look at other ways to connect our IoT devices. Now, one good way to do it is what's called LoRa, long range, and that's radio waves, and these travel miles. So you can have IoT devices around your waterhole, sends a signal to say, yeah, I've detected something, sends that small packet of data over LoRa, and that can travel miles to the nearest base station. Have one base station, then multiple miles around it, you have all your different detectors. That's great, works really well. Low power as well, so it doesn't drain your batteries much. But LoRa can only do small packets of data. It can do I've detected an elephant, but it can't do the image. It's not powerful enough for the image. We could use cellular. Sometimes you have good cellular reception, but cellular can be very expensive. If you're sending every time an animal moves in front of the sensor, we're sending an image to the cloud, that could get very, very expensive. So we need to think about connectivity and bandwidth all the way through. How can we do this in a more efficient way? We'll just take a quick detour on connectivity to mention one of my favorite stories about connectivity. There's a Twitter handle, Internet of Sugar Honey Iced Tea. Yes, there's a swear word in the name. I highly recommend you follow them if you don't mind swearing, because they show off some really great examples of IoT gone wrong, including in this case, a Ferrari, 200,000 euro Ferrari, someone parked in a parking garage. It said there's an update available. They tapped install the update, and the car got bricked. No connectivity, couldn't update, couldn't get out of the update cycle, so the car got bricked. They had to fly someone in from Ferrari 200 miles away to come and unlock it, just because there was no connectivity. So you've always got to think about connectivity. If you have a smart thermostat and the Wi-Fi goes down, you need to better heat and cool your house. You don't want to find your house is freezing because you can't turn your heating on because there's no Wi-Fi. This Twitter handle's got a load of examples of this where people were unable to vacuum their house because a cloud provider, one of their regions had gone down, and their smart vacuum cleaner couldn't connect, things like that. So always got to consider connectivity and bandwidth. Now, when considering connectivity, one thing you can think about is what's called edge computing. So edge computing allows you to run cloud computing things on your local network, not in the cloud. So the reason it's called the edge is because we have this cloud, data centers around the world that make up the cloud, but then you can have computers that you own in your network that are connected to the cloud and act like they are part of the cloud. So with my little IoT device, when my polar bear popped up, we sent a picture up to the cloud. But what I could do is I could take that same AI model that I've built, deploy that to a device that I have running locally, and then manage that from the cloud. And that way, when I send my image, I can send it on my local network, not up to the cloud. So for example, I could take this model. I go back to my AI model. I take my model, I click export, and I export a Docker file. If you're not come across Docker, it's a way of packaging up an application that kind of is agnostic to your operating system and kind of just sits there and just runs, doesn't care about your setup. So I could take a Docker file with my AI image. I could send that up to the cloud. I could say to the cloud, I've got an edge device configured. Configure an edge device that runs on my local network. The cloud will then take my model, deploy it to my edge device. My edge device is treated as just part of the cloud, deploys it to my edge device, and then I can then use that edge device from my IoT device. Sounds a little bit confusing, but let me just show you what I mean. Probably makes a bit more sense. So what I mean by an edge device is a device. So an edge device is basically a computer that you've chosen to run one of your cloud workloads. Okay. Now, I've got an AI model, and there's a lot of edge devices that are really good at running AI models. So a couple of examples here, there's a Jetson Nano from NVIDIA, people who make graphics cards. I can use this to run my AI model really fast, and I can run this locally. Okay, so you know what? Let me just show you what I mean. What I mean is I have got my model, and I have got, where's my code? I've got my AI model installed on a Jetson Nano, which is running in my house, and that is an edge device connected to the cloud. Okay, so I've got my exact same code that I just showed off. Make sure my one stopped. That's just stop that. Exact same code I just showed off, but what it's doing is connecting to jim-jetson.local. So it's connecting to an AI model that's running locally on a device on my network, not running in the cloud, and I get exactly the same results. You get my polar bear, up pops the polar bear, bang, detected a polar bear. And that's done it by talking to my Jetson Nano, which is in another room in my house, hardwired to my internet. And this is actually the output from my Jetson Nano. I'm just telling the logs here. If I just pop something else up, you see it's kind of run, it's done something, and it's detected, in this case, a lynx with a probability of 0.711. So the AI model is running. Now this AI model, I downloaded the Docker container from here, from my custom vision application. I then, in my IoT hub, I created an IoT edge device. This is my edge device, my Jetson. And in my edge device, I configured a Docker container and to say, load this Docker container from a container registry, which is it's like GitHub for containers. So I took my Docker container from my custom vision model, built that, deployed it to my container registry, and then said for my edge device, install this Docker container from this container registry. And then when I connect my Jetson Nano, I say, connect as an edge device with this connection string. It connects. Not that connection string, different connection string. Connect to the edge device with this connection string here. Then when my edge device connects, the cloud will suddenly take over control. It will manage the edge device and it will push the Docker container to that device. If my device breaks, I just get a brand new one, install the IoT Edge runtime that makes it work, set this connection string, and my model gets pushed down to my edge device. And so what I can do is I could have, say, a Jetson Nano in a lion-proof box in my water hole with a Wi-Fi connection that provides Wi-Fi around the water hole. All my IoT devices to detect animals can send photos over the local Wi-Fi to that edge device, get the results, send the results all back to my edge device, and the edge device can connect over LoRa and send all the results back up to the cloud. So I can kind of build an architecture using my edge device. So it's not just me sending it, hitting AI models to the cloud, it's me using an edge device to do that. So that way, I can literally just say, package it all up, put it by my water hole, and just connect over LoRa. So questions come through. It says, I have a security camera, but it does not have object detection. Can I program a Raspberry Pi and catch the camera and train it to catch any object? Probably yes. So as long as you can get a feed from your camera, you can then train it to do that. Let me see if I can find a great example. Because I know somebody who has done this. Here we go. So this is my good friend Paul, who's done this with his security camera. So this is a security camera in his house, and he's actually analyzing a live stream of what comes through. He's using an NVIDIA Jetson Nano because it's much faster than a Raspberry Pi, because it's got big GPU in there. But yes, you can do all that. And I'm going to just drop this in the chat. So it's a whole series of videos talking through how to do it. It's a whole lot of live streams, and he does doing this. So now how well you can kind of see in this, but he's detected cars, people, cats, dogs, buses, signs, trucks, things like that. What are the alternatives to the NVIDIA Jetson? Great question, great question. So the NVIDIA Jetson is, I mean, it's a $100 device. It's ridiculously powerful. And obviously, there's more NVIDIAs as you go up. Integras and TXs and all these different devices gets very expensive if you want to build a self-driving car. The NVIDIA Jetson is probably one of the best ones. You can get other accelerators. So this little one here, I don't know if you can see on the screen, this is the Coral AI board. It's a USB accelerator. You just plug it in and it can accelerate some things. Usually with most of these, all you need is like a different version of, say, TensorFlow, and that can then run on the accelerator board. There's Intel do a compute stick. So there's a load of different options. Some are USB sticks you plug in. Some are like with the NVIDIA Jetson, it's like a hardware board with acceleration built in. But it seems like every day a new one's coming out. Running AI models on the edge is a huge growth area. It's where there's a lot of stuff being done. So it's a huge area to look at. I mean, I just love the NVIDIA stuff. The software works really, really well. They put a lot of effort into it. They're stupidly powerful, and it ties up nicely with Azure. We've got a lot of good links to get your data from the NVIDIA devices into Azure and manage it from Azure. But just be aware, though, if you do buy one of the compute sticks, they may not work with your models. So, for example, I can run this AI model for object detection for polar bears on an NVIDIA Jetson Nano, and it'll be accelerated. If I run it on a Coral stick, it won't be accelerated. The Coral stick doesn't support some of the things in my TensorFlow model. So just when you look at the different devices, have to think about what you need to do. Because a lot of times you may have to recompile your model in a way that works on the particular accelerator. Jetson's great because it's a full Linux computer as well. So you just connect it to your monitor, keyboard and mouse, full Linux computer to help you program it. But yeah, there's loads around, loads of compute sticks, loads of manufacturers making them. So, but no, I mean, you can't go wrong with a Jetson Nano. But yeah, for $100, it's very good value for money for what you get. Okay. So that's IoT Edge. We've talked about the IoT Hub ecosystem. My device sends a message to IoT Hub. I can pull it off with an Azure function, save it to a database. I can then use AI to filter my data on the way in, and I can use IoT Edge, which is managed inside my IoT Hub, to deploy my models closer to my IoT device so I can filter my data without worrying about network connectivity. So this is great, but if I want to then do reports, I showed a couple of charts which I built Jupyter notebooks, and I had to build the code to save the data into a database and then just write the code to produce a report that comes out of it. What if I don't want to do that? What if I just want the thing to work? What if I just want to throw together an application really quickly? And this is where Azure IoT Central comes in. IoT Central is a software as a service platform built on top of IoT Hub, and it gives you a whole nice application you can use for accessing all your data, visualizing your data, and doing stuff with your data. So let me show you Azure IoT Hub. Let me just make sure my other demos are stopped. Stop you. I've got another demo here. Same thing, except instead of going to IoT Hub, I'm sending data to IoT Central. And this is IoT Central. My data is actually slightly different. I'm sending just a count every second. So, my polar bear's popped up. I'm sending this to IoT Central. And this is IoT Central. So this is a whole software application I've built without writing any lines of code. So I've got a dashboard here that shows that, oh, we had a lynx earlier, now there's no lynxes. We had a polar bear earlier. I'm seeing my location. My detector is in Churchill, in Manitoba, in the Hudson Bay in Canada. That's my device there. And so I've got these charts and graphs, and I haven't had to write any code. So IoT Central is a software as a service application. Basically, it's a web app you configure for your devices. You start by creating a device template. In your device template, you define what data you want your device to send. So I'm sending the count of polar bears, the count of lynxes. I can set up commands that allow me to send requests back to my device to do things. I can set up properties that exist only in the cloud. In my case here, I've got the location that doesn't exist on the device, just in the cloud. I can set this up and then connect with my created device. We're still secure, got to be like IoT Hub, got to be secure. Define a device, set that device in this template, connect the device with the connection details that I'm given, and start sending data. And then I can edit things like views, all drag and drop. So my device template, I've got a view, here is a chart. That's all, I can configure it here. All draggy droppy, I'm not writing any code at all, and I've got this whole nice application for visualizing my data, which is pretty cool. And I can set up things like rules. So if a polar bear is detected, send me an email. And again, it's all draggy droppy, choose my device, endangered animal tracker, if true, telemetry, polar bear count is greater than 0. Bosh, action, send me an email. Yeah, I don't want to say as easy as that, but certainly it's not, there's no code. It's a 0 code. You just choose the options, which means you can have operators using this, building up applications who can't code. So if people don't want to code, they can use this to build up things like rules. They can set up jobs that are run every day to send requests to devices. Set up data export, take my data from here. I can set up a destination to send my data to event hubs or blob storage or service bus or a webhook. Call a webhook every time data comes in, whatever I want to do. And so I can build my IoT applications really quickly in here without having to write any code. So this is a nice, fun way. You want to see your temperature value on a chart. IoT Central is the way to do it. And under the hood, it just sits on top of IoT Hub. So all the security that you get from IoT Hub, all the speed, all the power, it's there. This just gives you a nice application. And this is still, enterprise scale. This is big. This is powerful. Keurig, for example, who makes smart coffee makers, are using this to manage their new smart coffee makers. So they're rolling out millions of these devices around the world, all managed from IoT Central, which is pretty cool. So that's how we can build faster. Cool. So that's just kind of given you the kind of lightning tour around the various IoT services and looking at how we can use these in the example of animal conservation. We've looked at IoT Hub, IoT Edge, IoT Central, looked at how we can use AI, talked about how a data scientist and an AI engineer are your best friends when you're an IoT application developer. Now, how much does all this cost? I'm showing off all this stuff. This is Jim from Microsoft trying to sell you things, except this is all basically free. Everything I've shown off is free. aka.ms/free student Azure if you haven't signed up for your Azure for Students free account, $100 worth of credit. But things like IoT Hub, free tier, 8,000 messages a day. If you don't send, if you send more than 8,000 messages on the free tier, your messages just get lost. We never charge you, don't charge you. Hit the 8,000, we stop, done. Next day, 8,000 more, all free. Azure Functions, first, I think it's 1 million calls a month for free. So as long as you're not sending more than 1 million messages, that's free. You pay a few cents for storage. That's about it. IoT Edge is built into IoT Hub, so you get that on the free tier. If you want to host your containers in the cloud to do things, you may have to pay a few cents for storage, not very much. Custom Vision's got a free tier. So that model I trained, all free, didn't cost me a penny to train it or call it. IoT Central, there's a free tier, 7 days, don't even need to sign up. And after 7 days, your model just gets, your IoT Central application gets thrown away. Or we have 3 tiers with different pricing, with different number of messages each day, but every single tier, the first 2 devices are free. So as long as you never set up more than 2 devices, you'll never pay a penny for IoT Central. So literally everything I've done today, if you're running this for a year, might cost you $1, maybe $2 for storage. That's about it. And yeah, to answer the question there, do you have access to this app as students? Yes. Yep. So IoT Central, when you create an application, there's a free option. You don't even need to register. Otherwise, if you've got Azure for Students, you can use IoT Central. And all the other stuff is all available for students. So where do you go next? You want to learn more? where do you go next? And really the best place to go, aka.ms/IoT-beginners, and this will take you to our IoT for Beginners curricula, 24 lessons all about the Internet of Things. We start with the basics of devices, hardware, sensors, actuators, microcontrollers, single-board computers. We talk about connectivity, sending messages, low-level message brokers. We get you building a nightlight. Then we dive into projects. You get going with farming, so you look at predicting plant growth, soil moisture sensors, automating watering. Then you start migrating to Azure and understand the power of the cloud for doing everything, look at security. Then a project around location tracking, GPS data, which we store, visualize, and then do fences to alert when people enter, when your sensor enters and leaves areas. We look at AI on the edge for doing manufacturing quality detection, actually accessing that training models, running them from IoT devices, running them on the edge. We look at object detection for retail stock counting, and then we look at consumer IoT, and you build a voice-controlled smart timer. So all these lessons there, it's all open source, all free, all on GitHub. So dive right in, learn all the stuff. If you need the hardware, Seed Studios, one of our silicon partners, they sell the hardware kits for this. Go on their website, click a button, and they ship you the hardware and sensors that you need. You can choose between Raspberry Pi and Python or Arduino and C++. If you don't want to buy hardware, you can do the whole thing without buying any hardware. You run the Raspberry Pi code locally, and we have a tool we call Counterfeit, which simulates sensors. So it's a little web app that runs and acts like the sensors that you can do. And the code you write using Counterfeit is practically identical to the code you would write using the real hardware on a Raspberry Pi. So if you eventually do upgrade to the hardware, you literally copy and paste your code, delete one line, and the code will still run. So you can do the whole thing for free without buying any hardware if you want to. But that's a really good way to get started. This is all about teaching the concepts, and then the Microsoft products are just what the tools we use to teach the concepts. And then from here, once you've learned the basic IoT concepts, you can move on to Microsoft Learn. Probably heard a lot about this already. We've got a lot of great IoT learning paths that focus on IoT Hub, IoT Edge, IoT Central. So IoT for Beginners teach you the basics, and then all the learn paths, you can dive more into the actual using the Microsoft products to really build out your IoT applications. From there, then AZ220 is your IoT certification, one worth checking out, because if you love IoT like I do, get certified. It will really help with employability. And that's it. ak.ms/IoT for everyone has all the links for all the stuff we've talked about today. So thank you very much for coming. I hope I've sparked your interest in the Internet of Things. Please go off, do IoT for Beginners, learn about the Internet of Things, build your devices, have a play. This is a lot of fun. The devices, if you want to play with real hardware, you can get some relatively inexpensive bits and pieces. $35 for a Raspberry Pi is downside cheaper than any other computer you'll ever buy. Arduino devices can be just a few dollars. Think about it. Think about the sensors you might want to buy. Come up with some projects, and I'm here to help. As I say, all over the internet, Jim Bob Bennett. I'm here to help. Show me what you've done. Ask me if you've got any questions, and good luck on your journey with the Internet of Things. One question did come in. I mentioned that I programmed my lights by myself in Python. Yes, great question. So the lights here are WS2812B programmable LEDs. If you've used any device from Adafruit call these NeoPixels. And Adafruit have actually got a set of libraries. I've lost my mouse. There we go. Adafruit have got a set of libraries to control the lights. So it's my screen's still shared. So Adafruit have a whole lot of Python libraries to control these NeoPixels. In fact, let's actually find the library. So they have a load of this code. They have libraries for controlling these lights. So I plug my lights in, and these are addressable LEDs. So I've got, 140 or so lights on these, and I can access them by an index. So I use the NeoPixel library. I spin it up. I say, I've got 120 LEDs on here. And then I can just say, LED 1, I want it to be this color. And you give it the red RGB value, red, green, blue, and it sets it for that LED. So at the moment, mine are all pink. So I've set RGB values for that. But if I don't know how I see this one, if I do this option. I don't know if you can see it's kind of green at the bottom and then goes kind of yellow and then red at the top. It's blue right at the bottom, which you can't see, kind of mimicking kind of like a rainbow effect. I can say, pixels 1 to 30, I want green. Pixels 31 to 60, I want blue. 61, and so on. And I can use that to change the colors. And then, I'm just doing this myself in terms of the color setting, but there are loads of libraries you can get which can just do patterns, and you can do music. So you actually listen to music and then use that to control the lights. And there's just loads of Python libraries to do that if you want to do it yourself. The moment say I just use the NeoPixel libraries. This come in 1 second. Yeah, these lights come in a strip. Like, I'll show you. It's come like a big reel like this. So you've got each one of these little things here. There's an LED, and you can just cut them strip to length. Just see where these connections are. I can literally just cut along here, cut those, solder them if we want to add more. And it's just a little connector on the end. Connect that to a Raspberry Pi. Connect to a separate power supply, because these draw a lot of power, but connect a separate power supply and then connect this to the Raspberry Pi, and then say just use the NeoPixel library, turn all the lights on and off. So yeah, NeoPixels, really great LEDs. Under the hood, they are a, what is it? It's a WS2182 programmable LED. Yeah. Get a strip of these on Amazon for, it's like $25 for a strip of 150 of these LEDs. And they're great. Say you just cut them. You can cut them to suit, you can solder them back together. I just cut mine on these lines here, soldered wires on there, and then I've got wires going up the side. So the LEDs come along, cut, wires going up the side, next strip of LEDs. Yeah, great question. I love lights. I love things that light up. Can you suggest any beginner projects in Raspberry Pi or Arduino? Yes, aka.ms/IoT-beginner. IoT-beginners. So this is our IoT curriculum, and this is all project-based. So as you learn IoT, you can do things like soil moisture sensor. Soil moisture is a great first project. Because everyone likes plants. So you have a plant on your desk, soil moisture sensor goes in, and you just monitor the electrical signal coming off, and that gives you a measurement of the amount of moisture in the soil, and then you can connect that to a relay that controls a pump to pump water into your plant. So it's kind of a really good first one. You measure the soil moisture. When the moisture goes down, your electrical signal reading goes up, and then you turn on the pump to pump more water in. We'll explain how to do it in IT for beginners, but that's a really, really good first project. Another good one, I say, is lighting. Yeah, build a little nightlight. So when it goes dark, the nightlight comes on. That's always a good one. Light sensor on an LED. When it goes dark, comes on. You can also, with the kind of a lighting one, if you build up lights are always a great one, because you get that instant gratification of it lights up. So what you could do is you could build some lights. If you want to get really advanced, build some lights, connect them to the cloud, use IoT Hub to send a command to turn the lights on and off, use Azure Functions to actually send the command to the hub, and then you can wire up things like an Amazon Alexa to it. So you can literally do, hey Alexa, turn my lights on. That will call your Azure function, which sends a message to IoT Hub, which turns on your lights. So you can kind of build yourself advanced voice-controlled lights using something like an Alexa or a Google Home to control your lighting arrays, which is pretty cool. So that's kind of a good one. Really, it's what interests you. We've got, there's somebody I know, one of our student ambassadors in India, and she's really into stained glass. So she's got stained glass that when you touch it, lights turn on and off. So you can combine it with art. You can say, I've got this, I've got this sculpture with lights on it, and then as I interact with it, things change. So if you love art, IoT is a great way to build digital art. Other things, this gadget I've got here, I love this. This is a fun little gadget. This one. This is a Sunfounder Pi car. Let me just adjust my camera a bit. So this is a car with Raspberry Pi inside it. It's my Raspberry Pi inside it, and it's a full car with a camera. It comes with Python libraries, and you can write code to drive this around. So you can even set up AI models, recognize stuff with the camera, and get it to like follow a ball or drive around looking for things. And then I've set this up. I can control this over IoT Central, click buttons on IoT Central, and it drives around. So there's a lot of these kits you can buy to do this stuff. There's a lot of these kind of off-the-shelf kits. There's a company in the UK called Pimoroni. Where are we? Pimoroni. And they have a load of kits. Yeah, want to build an arcade machine? Here you go, build a Piecade. They have all the kits to do that. And they just have a lot of these different kits you can get for doing just all manner of different things, really. Little cars, keyboard buttons. You can maybe set these up to be Control-Delete or Control-C, Control-V when you're copying and pasting code from Stack Overflow. You can build a Mars rover. Yeah, I've got one of these mood lights. So I had this set up as a busy light. So whenever it connects to my calendar, whenever I had a meeting, it would go red to say that I was in a meeting. Yeah, there's lots of fun kits. So Pimoroni, a really, really good place to go to get kits kind of for this. As for Raspberry Pi or Arduino, it all depends on Arduino C++. So if you want to learn C++, it's a great one for that. Or with Raspberry Pi, most of the Raspberry Pi stuff is Python. That just seems to be kind of the standard. Let's say about soil moisture. Here's a good one. This is a Grow Kit plus Chili Pack. So this has got soil moisture sensors that you put in, plant some chilies, soil moisture sensors, and a little hat here that shows you the soil moisture. So you can see in the picture here, it's actually showing the moisture across the 3 different sensors. And then you could then connect this to a pump. Yeah, doesn't have a, so they've even got an auto watering tutorial. This is set up, and then this you buy some pumps and get some tubes, and and this even teach you how to do a whole automated watering thing with a pump. So look for kits like this. These kits are fun. They're very targeted to one particular job. And then once you've got it doing stuff, you can then work out how to connect this to the cloud. So this will just be very much a feedback loop. You can then connect to the cloud, maybe touch IoT Central, so you can kind of see your soil moisture levels on the go. Does that case, the Raspberry Pi you have, come with that hat? No, it doesn't. So the hat is a Grove base hat for the Raspberry Pi. Move my car out of the way. So this is the hat. This sits on any Raspberry Pi. The case I've got is an Argon Pi case. And the reason I like this case is this case has, is it this one? It's not this one. It's a slightly different one. Slightly different one. They've changed the cases. The reason I like this case as a case is because it's got this little indent here on the case. Little indentation there. You know what, let me show you my camera. So it's got this little indentation here to mount the camera. So I like this because I can then just take my camera, clip my camera in there, and it holds my camera straight for me. But no, they didn't come with a hat. The case, the GPIO pins come through the case, and I just push this onto there. These Argon cases are also good because they're made out of metal, which means they're really good for putting the heat off. So I don't have a fan on my Pi 4, but my case is warm. You know, if I need a hand warmer, I've got one here. So that kind of helps the heat get off. And it comes to kind of, if I don't want to have a hat on there, I can put a top on top. It's got like a lid that fits on top. So it doesn't come with it. But yeah, now these Argon cases are really good. They're good, solid metal cases. This is the top of it here, and that's, you know, proper solid metal, magnets as well. So take the hat off. This will kind of magnet on and clip on and hold on, quite sturdy. So I really like these Argon cases. They're not cheap. They're solid metal. They're not cheap, but they're nice cases. And then say the hat is from Seed Studios. It's their Grove hat, this thing here. And this is part of the Seed Grove ecosystem. So if you do a lot with IoT, you might find you're getting out breadboards and putting cables along and things like that. The Grove ecosystem is designed so you don't have to do wiring. So one of the classic mistakes that people make is with the 101 IoT project of making an LED light up. If you connect an LED to a Raspberry Pi, you will blow up the LED because it's too much power. So you have to put a resistor before the LED. So it's Pi resistor LED. And so a lot of people don't think they realize this. Oh, I've got a 5-volt LED, I'll plug it in and poof, LED gets blown. What the Grove stuff does is you don't have to worry about breakout boards. You don't have to worry about cables. So literally they have a standard cable. And so you buy, they've got 300 different types of sensor. So you buy a soil moisture sensor or a distance sensor or a GPS sensor or whatever, and they plug in with standard cables. So all the cables are the same, all the sockets are the same. On the hat, different sockets do different things. So you've got digital sockets for digital sensors, analog sockets for analog sensors, I2C sockets for I2C sensors, UART for serial sensors, and things like that. So as long as you know which one to plug it into, it'll work. They've got great documentation that shows you what to plug it into, but if you plug it into the wrong one, it just won't work. But it won't break it, and you don't have to worry. The LED's got the resistor built in, so you can't blow up the LED, things like that. So I hate wiring, I hate soldering. I'm far too lazy for that. I just want to plug it in, get my data to the cloud, and do the fun stuff in the cloud. So yes, I killed a couple of LEDs in the motor before I learned about resistance when I was younger. Yes, yeah, very easy to do. But kits like the Grove stuff from Seed is great because I just plug in my LED, it just works. I never have to worry about that. So yeah, great questions.